You're welcome to Good day, everyone. You're welcome to today's class. So today we'll be talking about logarithms. Okay, so logarithms of numbers. All right. So I need you all to understand something. What exactly are logarithms? Okay. Well, when you look at the index form of numbers, you realize something. You can actually write numbers in index form. For instance, if I have an 8, I can write 8 as 2 raised by 3. That's 2 times 2 times 2. Okay? So I can decide to write it this way. 2 times 2 times 2, which is 2 raised by 3. Okay? I can also decide to write 64 as 4 times 4 times 4, which is 4 raised power 3. I can also decide to write 9 as 3 times 3, which is 3 raised power 2. Good. Now, these are numbers and index forms. But indices or index form of number is closely related to what? Logarithm of numbers. Okay? We can even say 1000 is equal to 10 times 10 times 10, which is 10 raised power 3. Now, back to logarithm. If you look at 8, if 8 is equal to 2 raised power 3, we can actually say log 8 base 2 is equal to 3. That means log 8 to the power of 2 is equal to 3. So 2 raised power 3 is equal to 8. The same thing, we can also say log 64 base 4 is equal to 3. Also, log 9 base 3 is equal to 2. So what we're simply saying is 3 raised power 2 is equal to 9. Likewise, we have this log 1000 base 10 is equal to 3. Okay, so if you look at this very well, you realize that this is the same thing as saying 10 raised power 3 is equal to 1000. Good. So we can write logarithm in any base at all. Okay, but the most common one that we use in our calculation is logarithm in base 10. So we take logarithm in base 10 as the common log. Okay, now don't forget, logarithm in base 10 is not the only thing written in base 10. When we want to write numbers in standard form, we normally write them in this form: a times 10 raised power n, where a is a unique digit and n is the power of 10. Now, what's the connection between logarithm and standard form of numbers? Okay, I'll get to that in a jiffy. Let's find the logarithm of uh, these numbers. Now, log 10 base 10 is equal to what? 1. Why is it 1? 10 raised power 1 is equal to 10. Also, log 100 base 10 is equal to 2. Why? Because 10 raised power 2 is equal to 100. Now, we also have log 1000 base 10 is equal to 3. That is because 10 raised power 3 is equal to 1000. But is it only powers of 10 like 10, 100, 1000 that we can actually obtain? No. We can have other values like if I have log 875 base 10. Now, it may not be very easy to obtain the derived values without any assistance using tables or calculators. So what do we do in this case? Let's use our calculator first. We need to obtain something. Now, log 875, we'll be having here log 875, and that gives us 2.9420. Okay, That's equal to 2.9420. Now, why is this important? It's important because if you look at this, log 100 base 10 is 2. Log 1000 base 10 is 3. Since 875 is bigger than 100 but less than 1000, definitely the power of 10 will be more than 2 but less than 3, because 10 raised power 2 is 100 and 10 raised power 3 is 1000. So if 10 raised power 3 is 1000 and 10 raised power 2 is 100, then 10 raised power what will give us 875? It must be bigger than what? 2 but less than 3. So the logarithm here is 2.9420. Now, in most cases, logarithm of numbers usually have the whole part and the decimal part. The whole part is referred to as the mantissa. Sorry, the whole part is referred to as the characteristic, and the decimal part is referred to as the mantissa. Okay, so how do we obtain the characteristic and how do we obtain the mantissa if there is no calculator? Now, what do? We'll be using the four-figure table. We'll be using the logarithm table, okay? So that's the four-figure table to obtain the decimal part, that's the mantissa. And we'll be using standard form to obtain the characteristics. Okay, so how can we use standard form to obtain the characteristics? We need to understand how to write a number in standard form. And that is the next concept we're going to talk about, standard form of numbers.